Okay. So when it started. All right, so I guess, yeah, very quickly, super excited to have Dean with us today. So Dean is working on Agoric, which is a smart contract platform that tries to enable JavaScript contracts for all of the world and all of the blockchain ecosystems and beyond that, right?
Mm-hmm.
Yeah, super excited. I think Dean's been building distributed systems and smart contracts, I think, throughout his career in various places. So maybe I'll leave it at that and let you introduce yourself a little bit more and give us a bit of background on yourself and the team and take it away.
Great. I will. You can see my screen, I presume. All right. So hello, I'm Dean Tribble. I'm CEO of Agoric and one of the founders. We were founded in 2018, there we go, by really pioneers in the space of smart contracts. So I worked on the first production smart contract in 1988, 1989. This was long before blockchain, where really smart contracts are software that's enforcing the terms of a contract-like arrangement between third parties. So eBay, PayPal, Venmo, Airbnb, Uber, Lyft, those are all smart contracts with a trusted intermediary that's running the software that does the enforcement. Now, what blockchain brings with its replicated execution is a level of integrity that is otherwise not possible, that did not exist before blockchain. And if we get that integrity other ways, we might, but blockchain brings it to us with replicated execution and each machine sort of looking over the other's shoulders. So we've been doing smart contracts for literally decades, as well as large-scale distributed systems. We have a bunch of founders: Mark Miller, our chief scientist; Mike Jablon, our COO. He did voice over IP at Time Warner Cable when that was disruptive technology. And we've got, we've been on the JavaScript Standards Committee for 15 years, getting into JavaScript, key elements that make it now, control trillions of dollars of money out there, and so forth. So we've been across a broad spectrum of the industries. Whoops. We started, as I said, in 2018, initial investors of Naval, Polychain, and Zcash, and then had more rounds, or one more round with additional investors. We have advisors, Zaki Munyan, who many of you know, the RMIT economists. There's a team, Blockchain Innovation Institute, at the #2 educational institution for blockchain in the world, apparently, which is RMIT University out of Australia, and then Zuko, who launched Zcash. We also work closely with Brendan Eich of JavaScript and various others. Recently, over 2021, we had a bunch of what may be familiar names in the DeFi space, because we're heavily moving into supporting broad spectrum of very flexible DeFi, and so they're very excited about it, and that was part of our accelerated growth last year. So what are we doing, right? We are building a blockchain, a layer 1 proof of stake blockchain in built on Cosmos SDK. It is all about, the biggest differentiator sort of at the surface level is smart contracts in what I refer to as hardened JavaScript, what we call hardened JavaScript, which is a technology that locks down key elements of JavaScript. So it's still JavaScript, only it's not the malleable stuff that people worry about and sort of have historical nightmares about the security of. And it turns out that we've got other discussions about it, but it's an extremely securable platform where we can run arbitrary, untrusted JavaScript in a confined environment and give it, here you're allowed this authority and nothing else, knock yourself out, right? And on top of that, we build a smart contract framework where, when JavaScript first came out, when JavaScript was out before React, experts could do cool things, right? They could program interactive stuff, and it would be somewhat painful, but they could do it, right? But after React came out, 6 months later, beginners could do more reactive, more interactive, prettier, mobile first, scaling, internationalized, whatever applications better and faster than experts could a year before. And that's because it was the right kind of component model with affordances for the things that users needed to do in terms of mouse clicks and animation and whatever. And that's a powerful model that people are used to. So the big thing about being, in hardened JavaScript is 13 million developers can program it. You can use all the standard JavaScript tools and, development environments, VS Code, WebStorm, automated tool testing systems like Ava and Jest, all those kinds of things. And then on top of that, we have a framework where now the affordances are about exchange and pricing instead of mouse clicks and re-rendering. But it's the same kind of model, so that I can say, I've got my auction. Here's the JavaScript function I want to run when a bid comes in. Here's the JavaScript function I want to run when the auction closes. Sort the collection of bids, pick the top one, do an exchange, etc. Now, on top of that, we then add more safety properties, which I can go into later, called offer safety, which is one of the main reasons why our platform is going to be able to have actual smart contract, real regulatory compliant insurance for the correct execution of smart contracts, which is very, very important for, like the pension funds in the world that would like to invest in DeFi and can't. Okay, and then finally, on top of that platform, and I'll go through this set again. I guess I should have used the picture slide for this. We're building, part of our economy includes a stable token to make the economy work, and that taps into the $75 billion interchain ecosystem of assets that, Atom, Osmo, et cetera, that, they want to participate in DeFi, but they can't be leveraged easily into a stable token. And so this enables that to happen directly, and I'll talk a lot more about that. Any questions so far at that high level? Okay, so, pretty diagram, right? So we have the staking economy with validators and so forth at the bottom. That uses the underlying capital asset called build, BLD, and that's our staking token, staking governance, and you can also borrow against it in the economy with a separate issue. Above that, implemented in JavaScript, written in JavaScript with this component model, is the smart contract economy. And so there we have the stable token run that provides the grease for execution, right? I can talk a lot more about that, but right now where you're paying gas fees and you're doing trades in an asset that is extremely volatile, which any of the most of the assets, unless they're deliberately stable, are quite volatile. That's like paying your rent using Apple shares, right? You can do it. Barter economies lasted for a long time. On the other hand, we moved off them a few thousand years ago because an economy with a stable token, so that you can tell whether the price of rent today is the same as the price of rent yesterday. That really removes some sand from the gears of commerce and makes for a much better growth of an economy. So we have a stable token that is built primarily using CDPs, right? Using a MakerDAO style mechanism called vaults, where where you have an over collateralized loan, you borrow, run against it, you mint, run against it, and if the value of the vault falls, it'll be liquidated, right? And I'll talk a little bit more about that. But a couple of key differences, right? The first is that the collateral can come over IBC, right? We were co-creators of IBC. It was inspired by a bunch of work that we had done, myself and Mark Miller had done in the 90s, that then, Zucky and Jay and Ethan, realized, this whole distributed, independent agents, connecting with each other voluntarily, sovereign chains talking to each other voluntarily. How do you build large-scale distributed system out of that? And that's a lot of the work that we've done over the last many years. And so they adopted many of those ideas. So we can bring Atom, we can bring Osmo, we can bring your token, right? All of these things as capital assets over to be able to mint, run against into the vaults. Run gets minted, and it's what gets used for the market participants for the smart contracts, and things, the various DeFi dApps, NFT applications, whatever that might get built in JavaScript, where one of those elements is an AMM, right? So we have an AMM currently codenamed Kinetic. We'll see if that sticks. But the reason that's important is it is a part of the integrated overall run protocol. So I said, when a CDP runs, you've got an over collateral, you've got $200 worth of Atom, you mint $100 worth of run out of that, where run has parity with dollars. If the value of Atom falls, where falling by 50%, not likely at this point, but if the value of Atom falls to the point where it risks the collateralization of the run, then it gets liquidated. Unlike MakerDAO, it doesn't have to be liquidated off-chain. It can dynamically wake up. All of our contracts communicate asynchronously, so it can dynamically wake up and asynchronously liquidate on the AMM, on the kinetic AMM, and it does so in a rate-limited fashion. So again, we're embedded in a world of a lot of other networks. Arbitrage over IBC, not just to local chains, if you will, and local liquidity pools like Osmosis, but to chains on entirely other networks like Ethereum, via network connections like Axelar. Those are things that are critical to where we can rate limit the liquidation on the AMM, and then arbitrage will mean that we're effectively liquidating into the pool of the larger market, where we're paying, where the liquidation fee is the ARB fees that we're paying to people to transmit these transactions over the network. Okay, and then all of this, all of these things are paying gas fees in run. Right? And there's a couple of key ways in which that's interesting for this market economy. So the first, as I said before, right, if postage and rent is what gas fees are, which is kind of the thing I need to do in order to get my business done, which is not about your token, right? Then paying it in ETH, paying it even in, an Atom, that's a speculative token. It's just not, it's just, it can work, but it's not great from a sort of economic growth, economic efficiency point of view. Being able to pay in a stable token turns out to be a win. And so it's well integrated in all of our contracts, can consume and spend, run. And so that's one of the differences, right? But the other is that run does not go to the validators, right? They're not being paid rent for the contracts running on the system, because that has shown in multiple chains to cause them to be incentive misaligned with the people and the applications running on the system, right? You don't want the validators or the miners to be the slumlords that are now trying to raise the rent so they're getting some rake from your meth lab, right? You want it to be coherent business district where the rents are kind of predictable over time. It's the same yesterday as today. And, you can run a professional business that you can plan for what are your costs of execution and those kinds of things on top of this kind of platform, right? And so though the gas fees go into the reserve for stabilizing run, because that's what makes the economy grow. And then all the rewards for the stakers and validators, for the people who build capital at work to secure this network to make robust, safe composition in a stable economy work. All of those rewards come from the fees for minting and borrowing run, the fees for trades on the kinetic AMM, the fees for any of the market services that are part of this economy. Okay. So that's a whole lot to take in. That's what I wanted to cover in this slide. Any questions at this point?
So I guess there are transaction fees, right? They just paid and run, you're saying?
So the gas fees, transaction fees. So on currently, transaction fees are zero. There are transaction fees, gas fees. They're paid and run, but because there is not the incentive misalignment. So first off, because it's Cosmos, they'll generally be lower. At least for quite some time, because just a proof of stake is much more efficient than proof of work kind of intrinsically, from an execution point of view. But the other is because of the incentive alignment, it is not in the interest of validators to raise the gas fees beyond what is necessary to prioritize work. Instead, their interest is in growing the capacity to execute more economic transactions. And so that means as the gas fees rise, it's going into a fund that can pay to do the improvements to reduce the gas fees, right? My characterization, by the way, of getting, the fact that you're paying the landlord, it's like, ETH miners are rewarded for the amount of traffic on the freeways rather than the amount of business actually happening. And when you pay for traffic, you get traffic. That's the way those kinds of, and traffic sort of correlates with business, but not entirely. And no one really wants more traffic. That's just sort of a cost, right? So having that alignment means that even if it goes up, the as there are improvements in Tendermint, we're all incentivized to deploy them. If we had to move to hot stuff, if we had to grow to, Celestia and horizontal scaling, which we know how to do because everything, all the work between contracts are asynchronously coupled, it's quite easy for us to, or not quite easy, it's straightforward to scale the Agoric platform horizontally, where we can have multiple independent sets of validators validating different subsets of the contracts, and they're all communicating asynchronously between these different subchains. And so there's a lot of these mechanisms that are designed for scaling so that, as long as the incentives are aligned where validators want to help scale the economy just like the participants do, that really helps in terms of keeping those gas fees down. The other thing with respect to our gas fees is they're not paid by the user. Right? I don't go into the UPS store and pay for the use of the line and then pay for the time of the clerk taking my order and then pay for, I pay for some things, but not the air I'm breathing inside and all that sort of stuff. The business, if it wants to stay in business, figures out its costs and it pays to operate. And our payment and metering architecture is similar. A contract wants to make money, it needs to cover its costs, and then it can charge what it charges. And it just needs to make sure that it's making enough money to be able to cover the execution and storage costs for all the business that it's doing. And the more efficient it is, the lower its costs are, and that's fine. And then, as the economy grows, obviously there's more and more costs as there's more and more businesses, but I don't get halfway through a transaction with UPS and then get thrown out because I didn't have $5 in my pocket, right?
So how do you protect against like denial of service attacks?
So there are some. So there are some ability to charge transaction fees. So of course we have that are on the actual behavior of messages. It's just not paying for the execution. So I still have to, I'm sending a stamped letter to do business with a business who's, that operates with whatever cost structure it operates on. So I'm still paying the infrastructure to deliver and prioritize my message, and I may be able to pay prioritization fees. Some of this we aren't going to roll out in mainnet 1. We've got more designs that we're working on that will gradually roll out as we go forward. But those the fees for prioritization of delivery, that is the thing that you are in some sense bidding against others for. Those fees don't go to the recipient; they go into the stability fee to help stabilize and grow the platform. And so they go into the reserve for stabilizing the currency and growing the platform. And that does have to be paid upfront in run by the participants. But again, it doesn't. Once their message has been accepted, it's not a question of them sort of continuing to get metered payment for the service of the contract. That's up to the contract to cover. And it may, it may charge a fee up front in order for you to get in the business door, or the high priority door, or whatever it is. But that is something that is in the smart contract components that you plug together in various ways.
So I guess one more question. So then as a smart contract developer, so okay, I put my contract, I have like a balance, right? Somewhere of, tokens I'm going to use, right, to pay the fees. If I run out, then I go buy and like put it in my balance. And so I have to like keep monitoring this in some sense.
Well, no, generally not. I mean, because again, the fees, you're in control of how complicated your code is. The fees are generally order one for the work you're doing. Having a purse with a bunch of money that covers all of your businesses, and as long as you know that you're charging enough, from the fees you take from business, you just, are pumping into the same purse that you're paying your expenses out of, or some percentage. Having that be, turnkey is quite doable. Now, we need to demonstrate that, and we don't need that for run protocol, so we're not rolling that out in mainnet 1, but we will roll that out thereafter. Okay, so I'll hit a couple more things. We can obviously come back to any of these things. So this, I said there was the stack, right? So Cosmos Tendermint underneath. Above that is the Agoric JavaScript VM that runs the hardened JavaScript. That is, Endo.js is a project that is, that we run and are the creators of, that is the hardened JavaScript all by itself. Right, so we'll be able to do, so our protocol for communicating between arbitrary machines, where a blockchain is just a machine out of agreement, And so we can do blockchain to blockchain, fine-grained object messaging. We can do blockchain to a server machine that's running in my data center, or not yet, but soon we'll be able to do arbitrary object messages from my wallet running in the browser to an on-chain object and responses. And so we do a lot of our programming like that. And that's what, so if you're familiar with promises in JavaScript, they were the asynchronous non-blocking promises were something that Mark Miller and I invented back in 1988. And it was primarily not just for the async stuff that people do in Rust and in JavaScript, but it was for high performance pipelined messaging. So I could send a message, immediately get a promise for the result, and then send a message on that. And those both messages would go out in the same packet to the machine on the other side. Well, message delays in blockchain systems are now on the order of seconds because you can't process messages until you receive a block. And so that kind of pipelining is even more important if you're trying to do fine-grained, easy object messaging between chains or from a chain to a user application. This is, I don't know if that's probably too fine-grained, where I'm in the midst of building a smart contract, and a smart contract is just a JavaScript module. Is just a JavaScript module with a start function, and then it has functions, hooks. Where's the one that I'm working on that will take. This is a new version of our liquidation contract to liquidate assets when a vault is being shut down, and it takes a seat that controls the assets of a particular account and says, hey, liquidate these, and this is going to go through the process of breaking it up into chunks and selling it on the AMM. And it's this one is fancy, mostly it's comments, but it has 100 lines of JavaScript to be able to do some fancy algorithm of going, okay, as long as the AMM price is close to the Oracle price, otherwise I'm going to do this other thing with it, or I'll delay until the next block and see if the price recovers, or various strategies like that are all in this kind of a JavaScript application. And so it ends up looking very familiar to JavaScript developers. All right, where am I going? I lost my. There we go. Nope. Let me get my slide deck back. Yeah, there we go. Okay, and then we have on that the smart contract framework, which is Zoe, which is a thing where you get to say, all right, I just need a start function. It's going to take as an argument the authority to access all of the escrowed assets of this contract, and register JavaScript hooks to be the things that people can call from the outside. So now I'm an auction. I've got a hook for bids. I've got a hook for selling new items. Here's my functions. Knock yourself out, right? On top of that, we then build our smart contracts using exactly the same framework and using these components that are really designed as these DeFi Legos that can be put together. So on top of our AMM, you could add a smart contract that will get notified when the price changes, and if it crosses a certain threshold, sell off or redeem your liquidity position. So you can end up with a stop loss on an AMM that's less than 50 lines of JavaScript and understandable to millions of programmers. Right? So we build a bunch of those contracts in the same environment. All of the components are reusable for people to be able to build their own. Our go-to-market sequence here is we are looking to launch the Run protocol in the Cosmos ecosystem in the next 3 months. So we'll have a target of a RC0 in our DevNet by the end of May, and then we hopefully will launch shortly thereafter. And then following that will be a period of permissioned smart contracts of people building on it, building with it, being able to add, hedges or perps that leverage it or whatever it is that they can do. And then finally, late in the year is when we will open it up to arbitrary permissionless deployment of smart contracts, where we need more of the kinds of metering stuff that you were talking about, Sergey, of making sure that, that not just rate limiting from the outside, but if you've got a smart contract that wants to send a bunch of messages, it's got to be charged appropriately so it can't clog up the execution system. So Run protocol is interesting, especially from a bridge point of view, because as I said, there's this $75 billion ecosystem that does not have a stable coin based on those $75 billion of assets. And we know that a bunch of DeFi summer was because there were multiple stable tokens that could all trade against each other in yield farms and really power the growth of DeFi. Run protocol opens that up for all of these zones in the Cosmos ecosystem that are purpose-built, focused on a particular problem, whether it's Vega or Osmosis or what have you, or in some cases, they are themselves smart contract infrastructures. To us, like Evmos is the most important in the near future, simply because we expect a lot of the now battle-tested applications written for the EVM or to be brought over, the DeFi ones, so that those are the primary sinks for stable tokens. And so, all of the people with, as I said, all of these assets in the Cosmos ecosystem, if they can leverage those into a stable token and go participate in a, stable swap yield farm, that's a win. If they can go long on any of the tokens in the Cosmos ecosystem, that's a win. That's another big demand for stable tokens, is going long against a particular asset that combines the use of the AMM and the vault in a way that people typically know how to do already. So these are some of the key elements of that. I think that's kind of it. We've got Kepler integration. We work closely with MetaMask because they're using our hardened JavaScript for extensibility of the wallet on the MetaMask side, and we'll be using snaps to be able to integrate in with the Agoric chain when it launches. We are spinning out. We will have an Oracle network that is being spearheaded by some of the Chainlink node operators using a bunch of the Chainlink architecture, but it will be an independent network using the same node operators that we built in collaboration with Chainlink engineers, as well as a bunch of those node operators that also are validators for Agoric. And I think that's it. So questions, we can deep dive now.
I'm interested in, go ahead.
I was interested in what kind of guarantees the JavaScript VM gives you over regular JavaScript.
So there are several. So the hardened JavaScript is, we've been driving things into the JavaScript standards. Let me get out of sharing mode. We've been driving things into the JavaScript standard, for the last 15 years to be able to lock down what JavaScript is, and everything from strict mode to proxies and the details of promises and the whole freeze architecture. So basically what it does is there's an operation called harden that walks through the primordials, right? Detour. As an accident of history, JavaScript is actually more securable than most other programming languages. The reason is that the language was standardized in ECMA, whereas the bindings to the browser were standardized in W3C. And you've never seen a user mode, system mode separation defended as vigorously as committees defend their territory, right? And so as a result, any JavaScript computation in any existing standard compliance JavaScript implementation, the only authority it gets are from the objects that are in its global environment. And you can control the global environment. And so what we do is all of the, the other wrinkle is that JavaScript starts with, everything is malleable. I can take array iteration and I can say array iteration is find my public key or my private key file, send it to another country, and then iterate the array. And how would you ever know, right? Because anyone can change it. That means you're subject to bugs or security vulnerabilities or security exploits in any library you load. Now, it turns out that's true of Rust, C#, Java, all these other things. They have no confinement for the dependency graph, and that's a terrible place to be. In JavaScript, what we have been able to do is, first off, we can lock down the global environment. So what we do is recursively freeze it all, harden. It's called harden. So now you cannot go in and change what it is that array implementation means. You can't change what it means to print an integer, right? And so now you're running in an environment that is as specified in the standard as the initial environment for JavaScript, right? So it's standard JavaScript. There are a few libraries that cheated at one point or another, and everybody thinks that's bad. And when we file the tickets, they all fix it, right? And so most JavaScript just works, except for a few things that really are deliberately shims that you load in before this in order to, for example, run a test environment. And so So what that means is we can now run confined JavaScript that has 0 authority, and we give it exactly specifically in the global the authority that we want. So we can, in that environment with the realm stuff and with this whole hardened JavaScript stuff, we could run a web environment on Node or a Node environment on web, because when the JavaScript runs, it can't see that there's a file system underneath that was locked away from it. And so that means that we can run arbitrary JavaScript. It has what's called ocap properties, where if I did not give you access to an object, you cannot get it. And so that is the primary guarantee out of which we build security patterns, where it's based on this reference graph. Here's this thing, it can access its object that lets it get to its contract details, and it doesn't let it get to the contract details of some other contract. We add to that, so that was sort of the first couple of big things, and that means we can run confined JavaScript, and our contracts use that. Then the first thing they run is the Zoe framework, sort of like libc, that is, what do I want to provide as this convenient APIs for the contract, so it can have safety properties that we like and make it easy to trade and price and all that sort of stuff. And that ZCF is loaded with, and here's your 3 privileges to be able to send messages to, the issuer of tokens or something like that. And then it can run, and that's all it can do. All of this is then running on, we do all of this, we're able to do all this in Node. All of this runs inside of, again, any standard JavaScript compliant environment. And then what we use the moddable JavaScript runtime. So that is a embedded systems runtime. It runs in, modern Whirlpool, washers and dryers and Maytag and so forth. And the nice thing about it is it's simple, right? It's simple memory model. It's not doing jitting. It's not moving too fast for safety. And so it's much more amenable to security review and security audit. And we just, in fact, completed one a couple of, we did in, I don't even remember now, but just got the report out. It's up, should be up on our website. And so we launched one of those for each VAT, and then we run into confined process as well. So we've got JavaScript confinement, we've got OS level confinement, and that provides lots of protection, isolation between these different contracts all running, and they all can communicate asynchronously. So our kernel, the kernel VM, the Agoric VM here, that does asynchronous messaging and promise-based messaging between all these independent contracts, and so, from their perspective, the contract is just sending an async message to, some issuer to say, hey, deposit this money into my account. And it can't tell whether it's sending to a contract that's on chain or on another chain over a bridge or what have you. It's still, secure, reliable, asynchronous messaging that does it. So that's probably a bigger answer than you wanted.
Oh, that was great. Thank you.
You got a question, Sergey?
Yeah, but I guess just to follow up on that a little bit more. So you mentioned that it's actually like, JavaScript is more secure, but so it looks like the approach that you're taking is sort of kind of confinement, right, of JavaScript. Okay, you restrict like the libraries, right, like everything is well defined, like, whatever gets loaded. I guess, could you take then the same approach for, like Rust, right, or Cosm Wasm, or like, Solidity? Like, why do you think it's easier to, I guess, confine with JavaScript than other languages?
The reason is because that level of isolation and compartment is pervasive in the language. So when I load a library, I can load it in a confined compartment, so I'm using it at arm's length. I don't know if you remember the something string. I didn't even remember it now. There was a compromise of a wallet, because the iStream library, well-used library, but the maintainer said, okay, I'm done with it now, someone else take it over. And they picked someone in the community, which turned out to then do a very clever backdoor. So the iStream you loaded would detect whether you were inside of this particular crypto wallet, and if so, it would go grab your key file and send it off to some other country. And that literally happened, right? But the problem was not with the library. And the same problem would have happened in Ruby or C# or Cosm, Wasm or Rust or any of these things, because they're loading a library. GitHub knows that. I mean, we got lots of statistics that say that 97%, on average across all of the applications on GitHub, 97% of them is libraries loaded from other people, right? And only 3% is the actual logic of the library. There's no realistic model in which you actually read all the code for any code base of sizable quantity. You're using other people's libraries. The issue is you'd like to be able to load the iStream library, which does not need file system access and does not need network access, and if it asked for that, that should be an issue. And the problem is there's no way to tell in any of these languages how to do that, right? With Lava Mode, which uses our hardened JavaScript, Lava Mode is something we did in collaboration with MetaMask, that lets you load libraries where it does a static analysis of your JavaScript program, of any JavaScript program. Sees, oh, iStream, it doesn't load file system. I get to load it in hardened JavaScript. That means that the only privileges it gets are, none, right? It has no object that represents file authority, network authority, what have you. And so now, if they upgraded iStream to the version that wants to steal your private key, it would try to go look for a file system object, and it simply would not be available to it, right? And what ends up happening is 80% of the libraries that, in this particular case, and we saw this in both all of the Cosmos code or Tendermint.js and in Web3.js and in the stuff that MetaMask loaded, 80% of it used no authority. That means 80% of the libraries are just green because they're locked down, and they could screw up and be a poor streaming library, but they can't steal your code and send it to some other country. Right? And then some smaller percentage have some yellow things, right? Turns out in Node APIs, Node process is what you need in order to find out what architecture you're running on. And oh, by the way, if I gave you process, you can also exec arbitrary code running as the user for Node. Seems like a bad combination. And so what it does, it writes down a profile and says, yeah, you're using a sensitive authority, but you're only using this operation. I'll give you a remediated version of that only has the operation you're using, so that if you upgrade tomorrow to the version that wants to get at the file system, it will fail. Right? And it'll raise an alarm that, hey, this thing used these privileges, now it's trying for these privileges. That seems bad. What do you want to do? Right? And that's statically analyzed to build time, all straightforward. The thing about C programs, WASM programs, EVM programs, Solidity programs, etc., is you're loading in these libraries, you never looked at them, but fundamentally, once they're running instruction set, they have access to all of memory. So when you've got a WASM program, I grab this library to do this thing over here. Somewhere in my memory space of WASM is the ability to read and write files. Otherwise, nothing in WASM has access to it. So I had to grant it to the compartment. The problem is any code in the compartment can reach any other part of memory and use any piece of authority, right? So the other thing is, WASM is not actually a programming language. So that pattern recurs where in Rust, I can have a Rust library and it doesn't, and partly, even if Rust gave you the compartmentalization you would like so that I can tell when I load this Rust library that it only has the authority I gave it, which I believe you cannot do in Rust, but if you could, it's still the case that that's not what's being executed. What's being executed is compiled WASM, and it may or may not follow those rules, right? You might have had compromised compilers, or someone might give you a program that has embedded in it these things that let it cheat. And it hasn't been analyzed with respect to that level of security, and it wouldn't help because the model of compilation means it's all a uniform slurry of instructions that can do anything inside that memory pool. And so the only way you get compartmentalization is by having different WASM compartments enforced by OS separation, as opposed to in-language protections that give you fine-grained protection, which is what you need to protect against library loading. And you can't do it without fine-grained protections in the architecture of the language, which most of these languages simply don't have.
So I guess, you can correct the analogy, but I guess so you know about SGX, right? Like the enclave, right? Which I think, a part of what they're trying to do is okay, you don't have any syscalls, right? Like you don't have any, multi-process applications, and you have to be very kind of explicit of what gets loaded there, and communication across them is sort of asynchronous, right? And then, there's a bunch of work, but how do you automate this? Take a program, sort of split it apart, right? You have very explicit calls and you define which ones are allowed to do. So is that I guess similar model that you're trying to get to without the enclaves, but at a software layer, or?
Yeah, but except what I do is I simply import iStream and you use it. I mean,
Sure.
The thing is that when I imported it, I didn't give it authority. Why is it able to do anything except what I asked it for? And if I want to give it authority, I say, here, import it, and here's your file system, right? And it could be a subset of my file system. So fundamentally, the issue is, OO programming turns out to really work well for this, right? When you surface this security model, it just looks like an OO component library. When I grab a widget, I don't expect this widget to splat all over my screen if I embedded it inside of a menu. I expect it to appear in the menu, and that's kind of it, right? That's exactly the kind of confinement that I expect that people are used to without having thought about it very hard, and they really program to that model mentally, without having to think about it very hard. And so a lot of what our hardened JavaScript lets you do is, when people write JavaScript, they really are not expecting array to not be what they expect, right? And hardened JavaScript means that that expectation is met, whereas in JavaScript by itself, it's not. But, there are cases where, you'd expect the same thing in Java or Solidity or whatever, but, there have been multiple security exploits in all those VM environments where the difference between what the programmer could express in the language and what the attacker could do in the JavaScript VM, EVM, or WASM, the fact that those were different meant that you could scoot a security hole into there. And so, you weren't actually executing the library, the language that the programmer thought they were writing, basically.
Mm-hmm. So that's pretty interesting to hear. I guess, like the general concern here seems to be like access control and preventing sort of that on the JavaScript side. But it seems to me like a lot of the smart contract bugs are because, like just programming mistakes where like someone doesn't, enforce things like, they doesn't check things, right? So like the benefit of Rust or like a functional language or other languages people have been creating is to really like, give a very strong type system and sort of enforce safety at the programming layer. And like it doesn't seem like this solves this at the JavaScript layer, right? Like how do you sort of prevent that?
Okay.
And how people are used to like, coding JavaScript for web applications, like if they use the same approach to write smart contracts, like that seems to be concerning.
Right. Okay. So there's several levels of answer to that. I don't have any problem with Rust. In fact, I have just this arrived today, and I have the digital version of SQL. So I don't and we did a snapshot. We did an early version of our kernel in Rust in order to get the types right and all that sort of thing. So there are three answers. So first off, JavaScript has TypeScript. We do a lot of the type stuff so that people who want to program with types can. We think that's valuable. I've done a lot of my work in type systems that were similar to Rust, called System C# or M# when we did the secure operating system at Microsoft. So we have a lot of respect for that. That having been said, doesn't get you security at all. It gets you some amount of reliability, which is good, but it does not get you compartmentalization of risk, sorry, someone's at the door here. And what we do for OCAP and the general OCAP model is partitioning of graphs. So I don't care what the code is in that compartment over there. I know nothing it does can get at these objects over here that have my money. And so I don't need to know the types. I don't need to know the instruction set. I don't need to know whether an attacker slipped something in. Nothing it can express can get over here because the graph connectivity doesn't let it. And that lets you prove stronger properties, but in a different dimension, right? Sort of low-hanging fruit in each dimension. But we found that in commercial systems, that turns out to be hugely valuable. So is type safety, but they're unrelated. So there's, we have some types. This model gives you safety and security in these various other ways. One second. Sorry about that. And then the final thing, what was I going to say? Oh yes. So we also are focused more on API-like safety measures. So let me describe offer safety because it's actually pretty important and it's one of the key elements of the Zoe infrastructure, right? In the user interaction model of most of the blockchain world, messages it's what I characterize as send money to a random number and hope something good happens, right? You go through this interaction with beautiful user interface to say, I want to swap, 10 ETH for 30 Atom or whatever it is. No, I guess it's more than that. But I want to make this swap. I push a button and up pops a dialogue that says, so you want to send 10 ETH to 0x947732? Right. And that's not a model that normal humans can do. So in our JavaScript framework, because we have the ability to do this kind of component framework, which turns out the architectural elements of ETH get in the way of this kind of composition. Instead, I send the offer where the assets go into escrow in the smart contract infrastructure. The contract is notified, okay, there is an offer. Someone will give you this much ETH for that much atom. The only way the contract can get that ETH is by satisfying the proposal that the person providing the ETH required on their ETH. So they said, it's quid pro quo. I will give you this much ETH if you give me that NFT. And the only way you get that ETH is if you do an atomic reallocate to take the ETH into your purse and put the NFT in mine, right? And that's enforced by the infrastructure, and the infrastructure then provides what we call offer safety, which is you either get what you want or you get your assets back, right? And that's a safety property that is higher level, like other safety properties. It sort of takes 80% of the bugs off the table, right? Type safety takes 80% of the bugs off the table. Concurrency safety, we don't have reentrancy bugs, takes 80% of your concurrency bugs off the table. Memory safety takes 80% of the bugs off the table. You're still a lot of bugs, right? But each time you're taking this whole class of bugs and just removing them. And now you have to focus on the ones that are remaining. Well, offer safety is this kind of issue at a higher level where there's this class of bugs where you have perfectly correct code that will deliver money to a number that no one can decrypt. And now you never get it back, right? There are billions of dollars lost to these things. So when I talk about, Evmos is great because you take these battle-tested applications and deploy them in Cosmos, but as a place for innovation, man, they've already paid, $8-9 billion in order to battle test those things. That's a pretty big loss for, even for contracts as valuable as those. You'd like to do better. And for that, you need a different model. Types are not a different model. They're helpful, but they're not a different model. And the model is important. And, then the last thing here is, and I think Rust will have a place. We will certainly re-implement some things in Rust. We will make it so our asynchronously coupled compartments will be able to be done in WASM, but that's a couple of years out. The fundamental thing, if you want the world to move into the world of smart contracts, you want the world's programs to be able to program there, is we have to meet them where they're at. And there's a lot of JavaScript programmers out there. So what we want is provide a safe environment for them. And the safe environment is, I'm glad you're a JavaScript programmer. Now go learn Rust. It's wonderful. That's great. And 5% of them will do that, but there's another 13 million that won't, right? And so we want smart contracting for those too. And so there we do as much as we can in terms of providing supports around type, but more importantly, we provide offer safety. We provide this safe compartmentalization. So even if there are bugs, you're limited in the risk of loss you have, patterns to make it robust for people to automatically get their money back, those kinds of things. And these are, I think, complementary with type stuff. And gradually we'll roll that model into other languages, but that's quite a ways out.
Thanks.
And we've done, by the way, so this, I said we did promises in '88. We have done the basic architecture of event-based concurrency with asynchronous messaging between confined compartments that predates blockchain, right? That comes from secure OS architecture stuff that we've worked with. And so we've done it in Java, C#, Tickle, Corba, OCaml, and I don't even remember some of the, and JavaScript. And of those, because of that user mode, system mode separation that I mentioned, JavaScript turns out to be the strongest, the easiest to make secure and the strongest, because you can't write a program that magically gets access to some authority. Whereas in Java and C# and others, there's just so many things in the computational model that you can get access to that give you authority over other parts of the program. That it's really hard to lock those down. And you end up doing what's called taming, where you say, okay, we're going to expose lock, but we're going to remove the facility to lock the entire world, which otherwise any C# program can do. And that seems bad. That seems like a vulnerability that now an untrusted library can lock you up and do denial of service, right? And so, yeah, you can't do that in JavaScript. You can tell I like this stuff.
So I guess we're running low on time. Maybe a softball for you. Do you see any scope for collaboration between Axelar and Agoric?
Oh, heavens, yes, right. So we have multiple areas. One is, we're all about interop. and it's both, ACID interop, but also message interop. And the protocol, the architecture and protocol and the vision is this much broader, multi-chain world. That's been where we've been at the beginning. And so, even as far as the run protocol is concerned, we like the Axelar style of bridge to other chains. We want our assets to be available on those other chains, but we want them also to be able to bring their assets over as collateral, get some run, take it back, and now it's another stablecoin that participates in these environments. Very supportive of that. I also think you guys are an awesome technical team, and you are connected enough to Cosmos that I think of you as a Cosmos, related project, even though you're, well integrated into these other places. And so, so having run be something that people can pay on your system, having your token come over and be able to be collateral such that you've got reason in it to integrate and support that. Having build go over your system to other chains, being able to bring, ETH assets, Solana, Bitcoin, etc., over non-centralized bridges. Those are I think huge value for making this the extended interchain ecosystem thrive. And we took from the ground up being a programmability layer for an interchain environment. And so our abstractions make it easy to slosh assets back and forth. Real easy way to mint a new NFT, take it, move it over IBC to to Axelar, move it over from there over to Ethereum and sell it on OpenSea or whatever it is, right? And most of the people that are actually innovating in customer engagement or or fandoms or fan tokens or those kinds of things, yeah, they're all JavaScript programmers, right? And they're all innovating in best ways to engage with their band's fan club, right? Making it so that they can quickly do NFTs, but then make them available broadly across the crypto ecosystem. Robust bridges are a critical part of what that future looks like from our perspective, and that's not what we do. We leverage them. The other thing is you will have some programmability things. So like we have a project with Akash where they sell compute time on otherwise unused cloud hardware, right, and cloud deployments, and you can use it for a lot of different things. But it's it allows third parties to program to run on their stuff, but they are not themselves programmable. Particularly once interchain accounts come out, being able to have a simple JavaScript smart contract to be able to notice, oh, that machine has been reclaimed. Let me automatically restart that in another part of the cluster. Let me go buy some time and then sell it off to third parties. Let me, provide an auction for, time during the Super Bowl. I mean, whatever it is that is an interesting thing that someone might rapidly develop a new short-lived contract on. Man, that's a lot easier and safer to do it in the JavaScript framework than anything else. Being able to program other assets and other chains in JavaScript is hugely valuable. So you will have that, particularly for interop stuff.
Got it. And I guess, yeah, just to kind of just emphasize, I think some of the points you said. So because of your contracts and the way they compose is pretty much asynchronous from day one, right? Like the cross-chain communication interop makes it a lot easier, right? Because you don't have to sort of change the programming model, right? Like you take the contract, you can put it on that chain as long as there's a transport layer between them. It's the same as it was deployed locally.
Exactly. It's just the difference is latency, basically.
Right.
And
right.
so being able to do, so we will be scaling with, parallel chains that all just smoothly interoperate. We will have, we can connect to private and consortium chains using exactly the same model where some of the same DeFi Legos or contracts will come over and, it's an auction on the public chain for NFTs. It's an auction on the private chain for recovery of bill of lading for, whatever it is some freight company is doing. And they'll be able to interoperate smoothly. So I can pay for services. I mean, we did an example almost a year ago now of an OTC desk contract that you'd run on a private node, able to instantiate covered call contracts on the public chain in order to provide to someone the ability to sell stuff. So yeah,
I guess
cool.
One other quick question: is your hardened JavaScript is it a Cosmos module? Is it I guess can other chains take and use it, or is it kind of baked in the consensus right now?
It is somewhere in between. We implement our infrastructure, our entire stack as a Cosmos module called SwingSet, but it has our entire ecosystem and it is wired into the underlying infrastructure. It will be pull, because critical to that is offer safety, is paying with a stable token. That means you got to have the stable token, that sort of stuff. And so it's well integrated into our chain, but we certainly do plan in the future, and it's an explicit part of our foundation's charter to enable reuse of this technology on other platforms. There's the hardened JavaScript itself is already separable, right? That's in Endo.js, and it has, and we're gradually pulling pieces of technology out of what's specific to the blockchain and folding it into Endo.js, where it can get a open source life of its own. All of our stuff is open source, so someone could, clone us and take it and do a subset of the functionality, and yeah, probably someone will. But that's something that is, when we started this out, our goal is not to squabble over the current pie. Our goal is the bridge to the multi-trillion-dollar economy, and that's one of the key things of empowering JavaScript developers to do this stuff is, all the fintech developers that write software that control trillions of dollars, yeah, they all know JavaScript, right? They also program in COBOL, but we're not going to do that, right? Actually, not COBOL anymore. But you get the idea. And so, we're definitely supportive of making it more broadly accessible, but getting the chain off the ground is sort of the heart of launching an economy for these components, and it'll drive, the second stage. Originally it's like, here's an economy and here's all these DeFi Legos, we've got a bunch of start. With Run protocol launching, that second conversation is, here's $500 million of active trading, and if you could shave just a little bit off of the over collateralization ratio by adding your, insert contract value here, suddenly you get a whole lot of attention and a whole lot of business real quick, right? And that's just a different proposition for growth, right? Someone coming in and connecting up their perp contract, right? Would enable reducing the over collateralization required in vaults in various ways. Could be really valuable, right? We're not going to do that, but we will keep adding hooks so that people can extend the economy in various ways and plug themselves in, and that will really kickstart a bunch of DeFi, as well as things like, as I said, interchain accounts, so it's easy to integrate. Integrate other chains. We've got a Oracle model that it just looks like another DeFi Lego, so it's an information-rich environment. As I said, I can write a simple JavaScript thing that when the price crosses the threshold, grab my liquidity token and redeem it for those assets and do something else with those assets, right? And so all of those pieces plug together, but doing that next to a pile of executing contracts that are managing a bunch of money really makes it an attractive location to start innovating.
Awesome. I know we're out of time. Do you have to go? I guess.
I think I can take one or two more questions. Zucky wandered in. I have Zucky and Rick in the back room.
Nice. Say hi.
But they'll keep themselves occupied. So a couple more questions, then I can head out.
I have one question quickly. Can you say something about the performance of this?
Not yet. The answer is, in terms of its proof of stake, so it starts out, with factor of 100 or 1,000 faster than ETH already with Tendermint. Execution of JavaScript is fast. Anything that involves consensus is not. We were impacted by locks in the Tendermint layer, which we have helped them engineer out. So we, contribute back upstream and upstream bugs and changes and code fixes and reviews and stuff like that. We have a perf tool now but we're mostly focusing on what's the memory footprint and how does the memory footprint grow. It also measures perf, but that's not been a focus yet. We'll be doing that we just have a senior security and performance engineer that starts on Monday. They'll start up with we're having an internal, what's called a purple team with some internal and some external reviewers on our Run protocol implementations. But then he'll be taking over all the perf work, and I expect by the end of March, we'll have numbers like that. But, to do Run, first launch, we have plenty of performance for large scale Run protocol launch, right? Because much of the activity of it is IBC and off-chain activity, what people are doing with Run. The work to bring over assets, get a vault and bring it back, and get the Run and bring it back out, pretty minimal. You can even do that stuff in ETH, So.
Awesome.
Well, thank you all
Any
for your
other
time.
questions?
I hope this was useful.
This is great. Thanks so much, Dean. I think this is super interesting.
And if there are more questions, happy to come back and talk particulars, especially as we start rolling out the Run protocol. As I said, I definitely, see plenty of wanting to get bridged to other platforms, because that really gets you, that's how economies work, is with connectivity. And so that you guys are a big part of the future world of connectivity. So I'm excited about that.
Awesome. Thanks, Dean. We'll talk more.
Thanks.
Thanks a bunch.
Bye.
Yeah, very cool. Thank you.